Welcome to the deep dive. You know, we talk a lot about the big mysteries out there, the universe, black holes, all that cosmic stuff.
Right, the really grand scale things.
But let's zoom right in for a second.
Yeah.
Forget the edge of space. Think about the biggest mystery happening right here, right now, inside your own head.
Ah, yes. The simple yet utterly baffling fact of you. Your own subjective experience. It's everything, isn't it?
Exactly. I mean, science is incredible. Neuroscience can map every single neuron firing away in there. We can track the signals, the chemistry.
We can predict behavior pretty well, getting better all the time. We can see the inputs, the processing, the outputs.
But, and it's a huge but, science still slams into this massive wall when it tries to explain what it actually feels like to be you living through all that.
What makes you the protagonist? The
Yeah.
one experiencing your life story from the inside, that first-person view.
That feeling, that private internal world, that's consciousness. Comes from the Latin, right?
Yeah.
Con and scire.
Yeah, to know with. It's that sense of awareness of knowing you exist and are experiencing things.
So today, that's our mission. We're doing a deep dive. We're looking at the absolute cutting-edge philosophy, neuroscience, even physics, trying to get a handle on this colossal question.
How does that 3 pounds of, physical stuff between your ears, how does it generate this rich, subjective, technicolor reality that is you?
We've sifted through the sources you sent, synthesized the key ideas. This is your shortcut to understanding, well, arguably the greatest puzzle in science.
It's all about that jump from objective, physical processes, things we can measure, to subjective experience, something inherently private.
And the guy who really framed this whole modern debate, the philosopher Thomas Nagel, he nailed it.
He did. He said consciousness isn't about what the brain does functionally. It's about what it is like to be in a certain mental state.
That what it's like feeling, the taste of coffee, the sting of regret, the color red, that subjective quality, that's our target.
Right. And when researchers tackle consciousness, they almost never mean just one simple thing. It's too big, too slippery, so they break it down.
Okay, so let's map out the territory. What are the main ways they slice this up? Let's start simple. Awake versus aware. Seems obvious, but maybe not.
It's a crucial distinction. Wakefulness is basically your level of arousal. Are you responsive? Is the system on? Think deep sleep versus being alert.
Okay, basic operational level.
Exactly. Awareness, though, that's about the content. What are you actually experiencing within that wakeful state? You might be awake, sitting here, but maybe you're not really aware of the hum of the lights until I point it out. Then suddenly, it enters your awareness.
Got it. And he gets finer grained than that, right? The sources mention creature consciousness versus state consciousness.
Yeah. Creature consciousness is just, being a conscious thing. A creature that has experiences. A dog is conscious, presumably. We are. Maybe a bat, Nagel's famous example.
Right. What is it like to be a bat?
Exactly. State consciousness, on the other hand, is being in a specific conscious mental state right now. Like the thought, oh, I forgot to text back, or feeling a sudden pang of hunger. It's momentary content.
Okay, that makes sense. But the really big divide, the one that seems to drive all the theoretical battles, is phenomenal versus access consciousness. Let's unpack that. Phenomenal is the feeling part.
That's the heart of it, yeah. Phenomenal consciousness is purely about the qualitative subjective experience, the what it's likeness. Philosophers call these qualia.
Qualia, like the specific redness of red or the bitterness of bad coffee.
Precisely. The unique texture of velvet, the feeling of nostalgia, the sharp sting of a paper cut. It's private, intrinsic to your experience. You can't directly share your qualia.
Okay. So if phenomenal consciousness is the raw feeling, what's access consciousness? Is it just about what the brain can do with information?
In essence, yes. Access consciousness refers to information that's, accessible. It's available for you to report verbally, to use in your reasoning, to guide your actions consciously.
Like remembering where you parked your car and then using that info to walk towards it?
Exactly. That information is accessed, broadcasted somehow within your cognitive system, made available for various functions. It's about information being poised for use, functional availability.
This split the raw feeling versus the usable information that leads us straight to David Chalmers, doesn't it? The easy and hard problems.
It absolutely does. Chalmers made this hugely influential distinction. Now, the easy problems, they're anything but easy scientifically. They're incredibly complex.
Right, easy is relative here.
Totally. These are the problems neuroscience is actually pretty good at tackling, at least in principle. They're about explaining the photions. How do we discriminate between stimuli? How does attention work? How can we talk about our internal states? How do we control behavior?
So it's like reverse engineering a really complex biological machine. We can trace the pathways, figure out the mechanisms for how the brain processes information and produces behavior.
Exactly. We can map how light hits the retina, gets processed through various visual areas, and leads to you saying, that's a cat. We're explaining the function, the mechanism.
But then, boom, the wall.
The wall, the hard problem. Chalmers defined this as the question of why and how, all that physical processing, all those electrochemical signals firing. Why is it accompanied by subjective experience?
Why doesn't it all just happen in the dark, functionally? Why does processing redness feel like anything at all? Why is there a first-person movie playing inside?
That's the crux. Why the inner life? And this really brings us back full force to qualia.
These mysterious properties.
They're the raw feels, the intrinsic qualities. That specific shade of blue, the unique aroma of cinnamon, the feeling of being tired, even if you knew every single physical fact about the brain state corresponding to seeing blue, every neuron firing, every neurotransmitter released. Have you explained the subjective blueness itself? The hard problem says, no, you haven't.
And that's where the famous Mary the Color Scientist thought experiment comes in, right? It highlights this gap.
Perfectly. Imagine Mary. Brilliant neuroscientist. She spent her entire life in a black and white room, but she has learned everything there is to know physically about color vision.
She knows all the physics, all the neuroscience, wavelengths, cones, rods, V4 processing, the whole shebang, all the objective facts about red.
Every single one. Then one day she walks out of the room and sees a ripe red tomato for the very first time. The question is, does Mary learn anything new?
And the intuition, the gut feeling is, yes, of course she does.
She learns what it's like to see red. She learns the quail.
The raw feeling.
Exactly. And if she learns something new upon having the experience, something that wasn't contained in all the physical facts she already knew,
then the physical facts alone aren't the whole story. Consciousness must involve something more or something different.
That's the argument. And that gap between knowing all the physical, functional facts and knowing the subjective, what it's like, that's the explanatory gap.
It's like we can explain every gear and spring in a clock, how it keeps time perfectly, but we can't explain why it feels like something to be the clock ticking. Because, well, we assume it doesn't.
Precisely. Bridging that gap for the brain. Figuring out why we feel like something. That's the grand challenge driving all this research we're driving into. Okay, so facing this huge explanatory gap, researchers naturally end up in different philosophical camps about what consciousness fundamentally is.
And the dominant view, certainly in neuroscience and a lot of philosophy, the sort of default setting, is materialism, sometimes called physicalism.
Right. This is the view that ultimately everything is physical. Consciousness isn't some extra spooky thing. It is a physical process happening in the brain.
Mind equals brain, basically.
In a nutshell, yes. It's complex patterns of neural activity, electrochemical signals governed by the laws of physics and chemistry. It might be incredibly complex, emergent perhaps, but it's entirely grounded in the physical stuff.
And the evidence seems strong, right? You damage the physical brain, you affect the consciousness. Drugs change brain chemistry, they change consciousness, there's a clear dependence.
Absolutely. The correlation is undeniable. Plus, materialists often lean on a powerful argument called the causal closure of the physical domain.
Okay, that sounds technical. Break it down.
Think of the physical world as a closed system, like billiard balls hitting other billiard balls. Every physical event has a sufficient physical cause. Your arm moving is a physical event.
Right. Caused by muscles contracting, nerves firing. All physical.
Exactly. Now, if your conscious decision to raise your arm causes your arm to move, a physical effect, and if the physical world is causally closed, only physical things cause physical things.
Then your conscious decision must itself be a physical thing, part of that physical chain reaction in the brain.
That's the core idea. If you introduce something non-physical, a ghost, to make the arm move, you've broken the rules of the physical game. You've violated causal closure. Materialism avoids this problem by saying consciousness is already part of the physical game.
It keeps everything neat and tidy within physics. But I mean, it feels like more than just neurons firing, doesn't it? That subjective richness.
It absolutely does. And that powerful intuition fuels the traditional alternative, dualism.
Descartes' old idea. The ghost in the machine.
Pretty much. Dualism, in its various forms, argues that consciousness involves something fundamentally non-physical. Maybe a non-physical substance, mind stuff, or at least non-physical properties that physical stuff can have.
So mind and brain are distinct, even if they interact somehow.
That's the core claim. It really captures that feeling of being a self that's somehow separate from or inhabiting the body. And it's the killer but for dualism.
The interaction problem.
The interaction problem.
Yeah.
How does this non-physical mind, which by definition lacks mass, energy, physical location, how does it push around physical atoms in the brain?
Yeah, how does the ghost pull the levers in the machine? There's no physical connection point.
Exactly. It seems to violate fundamental physics, like the conservation of energy. Dualists have tried various solutions, but none have really convinced the scientific mainstream. It remains a massive hurdle.
Okay, so we have materialism as the mainstream, dualism as the classic challenger struggling with interaction. But the sources point to something else gaining ground. A kind of radical middle way, panpsychism.
Ah, yes. Panpsychism. This one really bends the mind. Its core idea is that consciousness isn't something special that emerges only when matter gets really complex, like in brains.
Okay, so where does it come from?
It doesn't come from anywhere. It's fundamental. Panpsychism proposes that consciousness, or at least some incredibly rudimentary form of it, is a basic property of matter itself, everywhere, ubiquitous.
Wait, you mean like my desk has consciousness, electrons have consciousness?
Potentially, yes. Not consciousness like ours, obviously, not thinking thoughts about philosophy, but some incredibly simple, primitive form of raw subjectivity or proto-consciousness is built into the fabric of reality, right down to the quantum level, perhaps.
Whoa, okay, so our complex human consciousness isn't created from scratch by neurons, it's built up.
Exactly. It's an aggregation or combination of these tiny fundamental bits of consciousness that are already present in the physical constituents of our brains. The complexity of the brain allows these simple micro-experiences to combine into the rich macro-experience we have.
That actually sidesteps the hard problem, quite elegantly. You don't have to explain how consciousness pops out of non-conscious stuff.
Because nothing is truly non-conscious to begin with. It dissolves the emergence problem.
Okay, but it sounds like it creates a whole new massive problem, doesn't it? You call it the combination problem earlier.
Precisely. This is the major challenge for panpsychism. If my brain is made of trillions of tiny little conscious bits, quarks, electrons, whatever, each with its own minuscule experience, why do I feel like one single unified conscious self?
Yeah, why isn't it just a chaotic jumble of trillions of tiny experiences? How do they bind together into my coherent viewpoint?
How do micro-experiences combine to form macro-experience? Explaining that combination mechanism without falling back into some kind of dualism or just hand-waving is incredibly difficult. It's the flip side of the hard problem, in a way.
Okay, so those are the big philosophical stances on what consciousness is. Let's shift gears now to the scientific theories trying to explain how it works in the brain. The nuts and bolts.
Right. These are models trying to pinpoint the specific neural mechanisms or functional architectures that give rise to subjective experience. These are the ideas being tested in labs.
First up, one of the classics, Global Workspace Theory, or GWT. Bernard Bars is the key name here.
Yes, Bars developed it, and others like Stanislas Dehaene have significantly advanced it neuroscientifically. GWT uses a great metaphor. The mind is a theater.
Right, I remember this one. Most of the brain's processing is happening off stage in the dark, unconscious, specialized processes.
Exactly. The vast majority. Memory retrieval, sensory processing, motor control, all the backstage crew and audience members doing their specific jobs without needing the spotlight.
And consciousness is the spotlight, the information currently on stage.
Precisely. A limited amount of information is selected, amplified by attention, that's the spotlight hitting it, and then it's globally broadcast across the stage, available to all those unconscious specialist systems.
So whatever thought or percept is currently in the workspace gets shared widely, allowing different parts of the brain to access it and coordinate action.
That's the idea. Consciousness acts like a fleeting, limited-capacity communication hub. Only one consistent scene can dominate the stage at a time. This global availability allows for flexible, coordinated behavior and, crucially, verbal report. If it's in the workspace, you can talk about it.
It explains things like why we can only seem to focus on one train of thought at a time.
Yeah, the limited capacity of the stage, and why things seem to pop into consciousness. It's information winning the competition for the spotlight and getting broadcast. It's a very influential functionalist theory.
Okay, next theory. This one sounds intense.
Yeah.
Integrated Information Theory, or IIT. Giulio Tononi.
Yes, Tononi is the main proponent. IIT is mathematically very sophisticated and makes some really bold claims. It's less about function and more about the intrinsic causal structure of a system.
And its core idea is that consciousness is integrated information, measured by this quantity.
Exactly. IIT makes a strong identity claim. Consciousness is identical to a system's capacity to integrate information, quantified by this measure, I-Phi. Subjective experience is a particular kind of objective causal structure.
Okay, integrated information, what does that mean practically? High-fi versus low-fi.
It requires two things. First, the system needs to have a large repertoire of possible states. It needs to be highly differentiated or informative. Think lots of possible patterns it can be in.
Okay, complexity.
But crucially, it also needs to be highly integrated. The information generated by the system as a whole must be way more than the sum of the information generated by its parts if you were to disconnect them.
So you can't just break it down. The whole is truly greater than the sum of its parts, informationally speaking.
That's the key. If you can snip the system into pieces, and the pieces are just as informative independently, then phi is low, and the system isn't conscious or is less conscious. High phi means irreducible causal structure.
Wow. So IIT implies consciousness isn't limited to brains. Anything with high enough phi could be conscious. A complex computer circuit, the internet.
Theoretically, yes. Consciousness becomes a fundamental property of organized systems, tied to their causal power. And this is where it gets really interesting clinically.
How so?
Well, researchers are actively trying to develop ways to measure something like phi in patients' brains, especially those with disorders of consciousness. Using techniques like TMS-EEG, they perturb the brain and measure how complex and widespread the resulting activity is.
Like a consciousness meter.
Sort of a proxy for it, yeah. It gives an objective measure of the brain's capacity for integrated activity, which seems to correlate well with levels of consciousness distinguishing vegetative from minimally conscious states, for example. It's hugely important for diagnosis and prognosis.
Okay, fascinating. Let's move to attention schema theory, or AST. Michael Graziano. This one seems to offer a different kind of explanation, almost debunking the mystery.
Yeah, AST is quite clever. Graziano argues that consciousness isn't some deep property of experience, but rather it's the brain's model of something else, its own process of attention.
Like how the brain builds a body schema, an internal model of the body's position and movement to control it.
Exactly analogous. To effectively control its focus, Graziano argues, the brain needs a simplified, real-time model of what attention is and what it's doing. That model is the attention schema.
Okay, so the brain models its own attention. Where does consciousness come in?
Here's the twist. This internal model, the attention schema, is necessarily simplified. It doesn't include all the messy, complex details of the underlying neural computations of attention. It's a schematic summary.
Like a cartoon version of attention.
Kind of. And because this model lacks mechanistic detail, it depicts attention as this sort of ethereal, non-physical thing, a mental possession, a subjective essence that directs processing. It portrays attention as having properties it doesn't literally possess.
And that model, that simplified, slightly inaccurate depiction of attention, the brain reports that as being consciousness.
That's the claim. Consciousness, in AST, is the brain experiencing its own attention schema. The feeling of awareness is the brain's internal readout of its simplified model of attention. So the subjective feeling, the qualia, is a useful fiction generated by this self-modeling process.
So the hard problem is basically the brain being fooled by its own simplified user interface for attention.
That's a good way to put it. It's a functional explanation for why we believe consciousness has these mysterious properties.
Interesting. Okay, what about higher order theories? These sound like they focus on self-awareness.
They do. The core idea of HIT theories is that a mental state only becomes conscious when it becomes the target of another higher order mental state.
So it's not enough to just have the feeling. You have to be aware of having the feeling.
Essentially, yes. Specifically, higher-order thought theory argues that a first-order mental state, like seeing red or feeling anxious, becomes conscious when you have a higher-order thought about being in that state.
Like, the raw data of red hits my visual system, but it only becomes conscious redness when a separate thought process registers, I am now seeing red.
That's the basic mechanism proposed. The higher-order thought paints the first-order state with the property of consciousness. Without that accompanying thought, the first-order state remains unconscious processing. It distinguishes raw processing from subjective awareness.
Okay. And finally, the really big one lately, predictive processing theories. Carl Friston's name comes up a lot here.
Yes, predictive processing, often linked with Friston's free energy principle, is a very influential framework now. It views the brain fundamentally as a prediction machine.
Not just passively receiving sensory input, but actively predicting it.
Constantly. The brain generates top-down predictions about what sensory input it expects to receive based on its internal models of the world. Then sensory information flows bottom-up. The crucial thing is the discrepancy, the prediction error.
The difference between what the brain expected and what it got.
Exactly. And the fundamental goal of the brain, according to this theory, is to minimize prediction error over time. It does this either by updating its internal models to make better predictions or by acting on the world to make the sensory input match its predictions.
So it's constantly trying to create the best, most accurate simulation of reality.
Right. And consciousness within this framework is often seen as emerging from this process, particularly related to the high-level stable predictions that form our model of the world and ourselves within it. The feeling of being me experiencing a stable reality might be the subjective correlate of the brain successfully minimizing prediction error at the highest levels.
And the free energy principle ties this to basic survival.
It does. Friston argues minimizing prediction error, or its information theoretic correlate, free energy, is mathematically equivalent to resisting entropy, the tendency towards disorder. So, the brain's predictive activity is fundamentally about maintaining the organism's integrity and existence. Consciousness could be the experiential side of this deep biological imperative.
Okay, let's ground these theories back in the actual brain. What have neuroimaging and lesion studies told us about where consciousness happens? Is there a consciousness center?
Definitely not a single center. That's one thing we're sure of. It's not like there's one consciousness module in the brain.
So it's network-based.
Highly network-based, yes. It involves a really widespread collaboration. You need the basic arousal systems, upper brainstem, thalamus, hypothalamus, basal forebrain, kind of keeping the power on and regulating vigilance.
The wakefulness part we talked about earlier.
Right. And these are deeply integrated with large swaths of the cerebral cortex, particularly higher order association areas in the parietal, temporal, and prefrontal lobes. It's a massive interconnected system.
But is there an area more critical for the content of consciousness, the actual experience?
Yeah, recent research points increasingly towards what's called the posterior cortical hot zone. This generally includes regions in the temporal, parietal, and occipital lobes TPO junction area. Because that seems to be where information from different senses gets integrated, where complex perceptual representations are formed. Damage here often severely impacts the content of awareness. Think of visual agnosia or neglect syndromes, even if basic wakefulness is preserved. It seems crucial for the rich, detailed experience we have.
Okay. And the sources describe a specific sequence for how a stimulus becomes conscious, this four-phase framework of awareness. It sounds very precise.
It is. It suggests a dynamic step-by-step process. First is detect, the initial sensory processing, where relevant stimuli are picked out by early cortical circuits.
Filtering the noise.
Then comes pulse, a rapid, massive surge of neuromodulators, things like acetylcholine or adrenaline, that basically amplify the selected signal, boosting it above the background chatter. It's like hitting an importance button.
Making sure the signal gets noticed.
Exactly. Phase 3 is switch. This involves actively suppressing or deactivating brain networks that could interfere or compete with the emerging conscious percept. It helps create a single, coherent experience rather than a confusing mess. Focus.
Clearing the stage, in the GWT metaphor.
Sort of, yeah. And finally, phase 4 is wave. The amplified interference-free signal then propagates through higher cortical areas in a specific sequence, building up the fully formed, detailed, reportable conscious experience. This whole cascade has to happen incredibly fast, within a few hundred milliseconds, for our perception to feel smooth and continuous.
Wow, that seamless feeling masks an incredibly complex, high-speed dance.
Okay, so classical neuroscience seems to be making progress. Why do some theories jump to, well, quantum mechanics, like OR?
Ah, yes. Orchestrated objective reduction, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. This is probably the most famous and controversial quantum theory of consciousness.
Their argument is that classical neuron firing just isn't complex or special enough to explain qualia, right? So they look to the quantum world. That's the motivation. They argue that the unique features of consciousness, particularly its non-algorithmic nature, according to Penrose, and the binding of experience, require something more than classical computation. They propose that consciousness actually arises from quantum computations happening inside microtubules.
Microtubules, those tiny protein structures inside neurons, like the cell's scaffolding.
Exactly. ORCH or R suggests that quantum states, specifically superpositions, can form within these microtubules, shielded somehow from the noisy environment. These quantum computations evolve until they reach a specific threshold defined by Penrose's theory of objective reduction, linked to quantum gravity no less, at which point they spontaneously collapse.
And that collapse is a moment of conscious experience.
That's the proposal. A sequence of these orchestrated collapses constitutes our stream of consciousness. It's an attempt to directly link consciousness to fundamental physics, bypassing the classical explanatory gap.
It sounds ambitious, but the sources seem highly skeptical. What's the big problem?
The absolutely massive problem is decoherence. The brain is, as neuroscientists love to say, warm, wet, and noisy. Quantum states are incredibly fragile. They need extreme cold and isolation to persist.
Like in quantum computers kept near absolute zero.
Precisely. In the brain's environment, any quantum superposition within a microtubule should decohere collapse due to interaction with the surrounding environment almost instantaneously. We're talking femtoseconds or picoseconds.
Way too fast to be useful for neural processing, which happens on the millisecond timescale.
Orders of magnitude too fast. So the vast majority of neuroscientists and physicists think that while quantum effects undoubtedly occur at the molecular level in the brain, they decohere far too quickly to play any direct functional role in the kind of large-scale coordinated computation needed for consciousness as proposed by ORC or R. The biological environment just isn't conducive.
So while intriguing, it faces a fundamental biophysical barrier. Okay, one last structural point. Emergence. Weak versus strong.
Right. This distinction is about how consciousness arises from the physical. Weak emergence is the standard scientific view for most complex phenomena.
Like wetness emerging from water molecules or traffic jams emerging from individual cars.
Exactly. Wetness isn't a magical property added to H2O. It's a result of the interactions of H2O molecules at a large scale. Weak emergence says consciousness is like that. A complex, perhaps surprising, high-level property that arises from the interactions of neurons according to standard physical laws. It's complex, but ultimately reducible and explainable by those underlying laws. That's the mainstream materialist bet.
And strong emergence.
Strong emergence posits something more radical. It claims that when systems reach a certain level of complexity, like brains, genuinely new causal powers can emerge that are irreducible to and cannot be predicted from the underlying physical laws governing the parts.
So consciousness would be a fundamentally new force or property that comes into existence, not just a complex arrangement of old stuff.
That's the idea. If strong emergence is true for consciousness, then physics as we know it is incomplete. There are causal forces at play in consciousness that you simply cannot derive from studying neurons or atoms alone. It hints at a form of property dualism, where consciousness has its own irreducible causal role. Most scientists are wary of invoking strong emergence unless absolutely necessary.
Okay, given all these competing theories and philosophical viewpoints, how are scientists actually trying to pin this down? What are the tools and methods being used right now to make progress?
The big push is to identify the neural correlates of consciousness, or NCCs. What's the minimum neural activity that's sufficient for a specific conscious experience? Find the NCC, and you have a strong clue about the underlying mechanism.
And how do they isolate that? The brain's always doing a million things at once.
That's the challenge. A classic approach is contrastive analysis. You create two conditions that are almost identical physically, but differ in whether the subject reports being conscious of a stimulus.
Like flashing a word on screen really quickly, sometimes too fast to see consciously, sometimes just slow enough.
Exactly. Or binocular rivalry, where different images are shown to each eye and your conscious perception flips between them, even though the physical input stays the same. By comparing the brain activity during the conscious moments versus the unconscious moments for the same stimulus, you can subtract out the basic sensory processing and hopefully isolate the activity specific to awareness itself.
Makes sense. But the sources emphasize a move towards no-report paradigms. Why is getting rid of the verbal report, "Yes, I saw it," so important?
Because the act of reporting involves a whole cascade of other cognitive processes: introspection, decision-making, planning the motor action to speak or press a button, working memory to hold the experience in mind.
All that extra brain activity can contaminate the signal you're looking for, the pure correlate of the conscious experience itself.
Precisely. It's hard to disentangle the NCC of the experience from the NCC of accessing and reporting the experience. No report paradigms try to get around this by using objective measures that correlate with consciousness but don't require an explicit report.
Like what?
Things like pupil dilation, specific patterns in EEG signals like the P3B wave, or even involuntary reflexes that differ depending on conscious perception. The idea is to find a reliable neural or physiological marker of awareness without needing the subject to do anything overtly about it. It aims for a purer measure of phenomenal consciousness.
It's clever. And to get the best possible picture, they're combining techniques now. Multimodal neuroimaging.
Absolutely essential. No single brain imaging technique is perfect.
Yep.
fMRI gives you great spatial resolution where activity is happening but it's slow. EEG and MEG give you fantastic temporal resolution when it's happening, down to milliseconds, but pinpointing the exact location is harder.
So you combine them, get the where from fMRI and the when from EMEG.
Exactly. By integrating data from multiple methods, sometimes simultaneously, researchers can build a much richer, more detailed four-dimensional map of brain activity as consciousness unfolds. Add in things like PET for neurotransmitter mapping, or TMS to stimulate or inhibit specific areas, you get a powerful toolkit.
Even with all these tools, though, that combination problem we mentioned with panpsychism, it still looms large for materialist theories too, right?
It absolutely does. Even if consciousness arises purely from neural activity, you still have to explain how all the distributed processing, color here, shape there, motion over there, sound somewhere else, binds together into a single, unified, coherent, conscious scene.
My experience isn't fragmented. It feels seamless, integrated.
Right. How does the brain achieve that unity? How do potentially billions of individual neural signals or computations coalesce into one phenomenal field? Explaining subjective binding is a major hurdle for almost all theories, whether materialist or panpsychist. Split-brain patients, where the connections are severed, offer fascinating clues. They sometimes seem to have two separate streams of awareness. Understanding integration is key.
Looking ahead, the implications here are just huge, particularly for artificial consciousness.
Massive. I mean, if we develop AI that becomes complex and integrated enough, could it become conscious? Theories like IIT suggest it's possible if the system achieves hi-fi.
But how would we even know? The other mind's problem, but for machines.
Exactly. We desperately need reliable theory-neutral tests or indicators for consciousness. Otherwise, how do we differentiate a machine that's genuinely experiencing something from one that's just incredibly sophisticated at simulating conscious behavior? The ethical implications are staggering. When does an AI deserve rights or moral consideration? We need better science before we get there.
And the impact is already being felt right now, in very human terms, in clinical applications.
This is where the research becomes incredibly poignant and important. Understanding the NCCs directly informs how we diagnose and treat patients with severe brain injuries, those in comas, vegetative states, or minimally conscious states.
Because sometimes people look unresponsive, but there might still be awareness hidden inside. Covert consciousness.
Precisely. Using techniques like fMRI or EEG, researchers can sometimes detect signs of conscious awareness even when the patient shows no outward behavioral signs. Asking a patient thought to be vegetative, to imagine playing tennis, for example, and then seeing the specific brain areas associated with motor planning light up in the fMRI scanner, just like in healthy controls. That's powerful evidence of preserved consciousness and volition.
Wow, that must completely change everything for the patient, for their family, for treatment decisions.
It absolutely does. It provides crucial diagnostic information, impacts prognosis, guides rehabilitation efforts, and raises profound ethical questions about end-of-life decisions and quality of life for patients who might be locked in but fully aware. This is where consciousness research saves and changes lives. Hashtag tag outro.
So, wrapping up this deep dive, it's clear that consciousness is this incredibly complex puzzle sitting right at the intersection of deep philosophy and cutting-edge empirical science.
Yeah, it's been quite a journey through the brain and mind.
Dang.
What are the absolute key takeaways we want people to hold on to?
I think first is just acknowledging the sheer difficulty of the hard problem. Explaining subjective qualia, that what it's like aspect, is the central challenge that really divides the field and pushes theories toward sometimes radical solutions, like materialism struggling with the gap, or panpsychism positing consciousness everywhere, or IIT trying to quantify it.
Right, that fundamental mystery of feeling remains. Second takeaway for me is that consciousness is definitely not in one spot. Forget the pineal gland idea. Absolutely. It's a large-scale, dynamic network phenomenon. It requires widespread brain areas working together, especially that posterior cortical hot zone for rich content, integrated with arousal systems, and unfolding through complex, rapid processes like that four-phase framework. It's a symphony, not a soloist.
And third, the field is moving forward. It's not just philosophers in armchairs anymore.
Definitely not. Sophisticated empirical methods like no-report paradigms and multimodal neuroimaging are providing much more precise data about the neural correlates of consciousness. We're getting better at characterizing what the brain needs to do physically to generate experience, even if the ultimate why remains elusive.
We're mapping the edges of the mystery with increasing detail.
Exactly. The study of consciousness is arguably one of the most exciting frontiers in science right now.
Yeah.
The theories are getting sharper, the tools are getting more powerful, and the philosophical questions are driving empirical work in fascinating ways.
So, as you go about your day, experiencing your own reality, maybe pause and think about some of these ideas. Especially that predictive processing concept, your brain as a simulation engine.
Right, constantly trying to predict the world and minimize surprise.
Which leads to our final thought for you to ponder. If your conscious experience is essentially the feeling of your brain running its best, most predictive model of reality, are you ever really experiencing the world directly? Or are you only ever experiencing your brain's most convincing internally generated movie about the world?
Something to think about. Until next time.
Happy diving.